Let's do this problem right here. The question is asking find both the x and y centroids of the composite shape below. So if you see the shape, it's very complex shape. So what you have to do is, in this case, we have to separate into simpler parts. So first of all, I can separate this. Basically, this circle is removed. So we have to remember this circle is removed. Circle is removed. So we have to consider that in mind. So in this case, we can separate into four different parts. So one is circle and the square with the circle, and there's going to be a rectangle and the triangle, right? So let's call this one 1, and this is 2, and then this is 3, and I separate this into two parts. So this is going to be 4, right? So we have four diagrams. So to find the x and y centroids, the equation is x bar is equal to sigma a x bar over sigma a, and to calculate the y bar, it's same thing, is sigma a y bar over sigma a. So in this case, we have to find a y bar, a x bar, and the sigma a. To calculate this one, I create table. So in this case, it's gonna have. So let's create the table. The first going to be parts. So I have four or sections, parts or sections, whatever you want to call. And this is my area. Area is going to be, so they are saying it's meter, so it's going to be meter square. Meter square, and let's go. And this is going to be my x bar. This is going to be meter, right? This is the distance. And then x bar is going to be meter cube, because meter square times meter is going to be meter cube. And then we have to calculate y bar, that's meter, and we have to calculate a y bar, that's going to be meter cube. So let's do this one. So if I take the circle part, the area of circle is 5r square. So this is they have given the diameter is 2 meter, so the radius is going to be 1. So if I calculate, it's going to be 5r square. We already know phi is 3.14, so I can 3.14 times 1 square is just going to be 3.14. And then x bar is going to be, so when we calculate the x bar, we have to be very careful. X bar or y bar, we set a point right here. So from this one we have to measure this. So in this case, this middle part, so centroid is going to be exactly in the middle. For this one also middle. For the triangle, centroid acts in the 1/3 of this triangle. So it's going to be, let's trace this and trace this one. So 1/3 of the triangle is going to be centroid. So that's general thing to remember. It's always 1/3 of the triangle. The centroid is going to be. So for circle, or for circle, square, and the rectangle, it's going to be exactly in the middle. But for the triangle, it's going to be 1/3. So it's going to be 4/3 right here, and also here it's going to be 4/3. So that's how we calculate centroid for the triangle. So these are these are the centroids, and then let's calculate the x bar. So in this case, for now we are doing the circle. So for the circle, from here to here, the distance. So in this case, this is 1 radius, and this is half of this square. So it's going to be 2 meter, and let's put 2 right here, and ax bar is going to be multiplication of these two, so it's going to be 6.28. 6.28. Then we have y bar. Y bar is basically the height from the bottom, from here to here, so it's also 2. And ay bar is going to be same thing, 3.14 times 2 is going to be 6.28. 28. And this is my part 1. Let's choose a different color. Okay, then I take the second one. Second one is my square. So area of the square is uh, base times height, so it's 4 times 4 is going to be 16, and x bar is going to be the distance from here to here is just 2, and ax bar is going to be simply the multiplication, it's going to be 32, and y bar is going to be the height, this is 2, also ay bar is going to be the multiplication of these two, it's going to be 32, and that's my second part. Now let's go to the third part. Third part is this rectangle. In this rectangle, a is going to be the base time length, so 6 times 4 is going to be 24, but in this case we have to be very careful about the x bar, because the distance is going to be from all the way from, this is the point we are selecting, so all the way from this point to this here, so we have to calculate all of them. So it's going to be 4 plus this middle of this is going to be half of this, so it's going to be 3, so 4 plus 3 is going to be 7 right here, so 24 times 7 is going to be 168, and then y bar is going to be the height, so it's basically the height between this is going to be just 2. So in this case, then we multiply this by 2. This will give us 48. Then let's move to the fourth one. So fourth one is going to be my triangle right here. The area of the triangle is going to be the width times the height divided by 2. So that's the equation for area of the triangle. So 4 times 4 divided by 2 is going to be 16 over 2, 8. And then x bar is going to be the distance all the way from here. So it's from here to here, so we have 10 right here, 6 plus 4 10, and 4 by 3 is 1.33, and if you add this with 10, so it's going to be 11.33. Then you have to multiply this by a 8 times 11.1 by 11.33, which is going to give us 90.64. Then y bar is going to be simply the height, so from here to here, so the height is also 4/3 of the triangle, so it's going to be 1.33, it's just 1.33. Then if I multiply 8 times 1.33, it's going to give us 10.64. Now we have calculated everything, but our purpose is to find x bar and y bar, so we had to x bar, y bar, so we had to know ax, a, and the ay. So these are the 3 columns we need: a column, ax column, and the ay column. So we have to add them all together and see what happens. So sigma a, let's add the a's together. But before I go further, we have to now, this is the main thing. Since I said the circle is removed, what you have to do is all the circle, whatever I calculated for the circle, I have to put the negative sign. So here it's going to be negative for the area, negative for the ax, negative for the ay. So when we add, we subtract this one from all of this together. So when we add, this is going to be subtracted, and when you subtract and add all of them together, what's going to happen is this is going to become 44.86, and sigma ax is going to be equal to 284.36, and sigma ay is going to give us 84.36. So these are the 3 values we need to calculate these things. So now let's calculate and see what we get. Then if I take the x bar is going to be sigma ax bar over a, and sigma x bar we calculated here is 284.36. 284.36. The unit is going to be meter cube, because area times distance, right? So it's going to be meter cube over the distance. We are dividing by the area. It's going to be 44.86. 44.86. The area's unit is meter square. So when you divide, you will get the length, and the value when you divide, you get 6.34 meter, and this is my x bar. And then I have to calculate the y bar. The y bar is going to be sigma ay over sigma a. Sigma ay we calculated here is 84.36. 84.36 meter cube over the sigma a is 44.86. And if you divide them both, if you divide both, you will get 1.88 meter. So this is my x bar and y bar. by bar. So therefore, uh, from this information we can say the centroid is going to be exactly here. So x bar means the distance from the base, so whatever the base we are getting. So from here to here 6.34, so let's say this is 6.34, so it's going to be somewhere here, and the height is 1.88, so let's say this is the 1.88, so it's going to be here. So centroid is going to be exactly right here. So this is how we calculate the centroid, and that's it. That's the main question. I hope you guys like this video. See you next time.